In lesson 7.4, we're going to be talking about equations that have two variables. If you look at this equation, y equals 4x minus 3, you notice it has two variables, a y and an x. Now, these two variables represent quantities that are going to change in relationship to one another. Now, most of the time, or all of the time, when you have two equations in a variable, two variables in an equation, those two variables represent an ordered pair that make your equation true. In this specific equation, we used x and y, which is helpful because in a coordinate grid, the ordered pairs that we use are x, y. So we know that we are going to plug in for our x value and then solve for y in this case. And we would be able to graph it on a coordinate grid because of the x and y axis. So let's say, for example, I give you the ordered pair 4, 12. And I want to know if 4, 12 is a solution to the given equation. Now, the only way for an ordered pair to be a solution is if the ordered pair makes the equation true. So if I'm looking at 4, 12, I'm going to take that 4, 12 and plug it into the equation, knowing that 4 represents my x value and 12 represents my y value. So I have y equals 4x minus 3. I know that y is 12 from my ordered pair. 4 times 4 for my x value minus 3. Now, just like we've done in the past, we know that we can draw that line down the center, just keep solving each side to see if it turns out true or not. To be true, that means they have to actually be equal. 12 stays 12. Oops. 12 stays 12. I have 4 times 4 is 16 minus 3. 12 stays 12 equals 16 minus 3 is 13. So does 12 equal 13? It does not. It is not a solution. So 4, 12 does not make the ordered pair true. Therefore, it is not a solution. So you would write that. Not a solution. All right, let's try another one. Let's try the ordered pair -1, -7. Okay, so again, it's y equals 4x minus 3. In this problem, my y is -7 equals 4 times -1 minus 3. I'm going to keep this straight here. So -7 equals 4 times -1 is -4 minus 3. Then I have -7 equals, and I'm looking at this, I have -4 and -3, which is -7. In this case, it's true. -4 does equal -7, so because of that, it is a solution. So -1, -7 is a solution. So now in these types of problems, it really doesn't make sense or have any value to understand if it's a solution or not. All this really tells you is if you graph this equation, y equals 4x1 is minus 3, on a coordinate grid, that 4, 12 will not be on that line, but -1, -7 will be on the line because it is a solution. Our real life situations are what make this topic more realistic. when you're talking about these real life situations, you're looking at the relationship between the variables. And we have two types of variables then. We have an independent variable and we have a dependent variable. So the independent variable is the variable that you plug in for. It represents the quantity that can change freely. So it's usually the x value in what we're talking about. So it's not always going to be an x value. So we're going to say that because if you're talking about a coordinate grid, it's the x, it's the thing that comes first. But in reality, it's the number that you know, the number that's changing, the number you're plugging in for. So the independent variable is your x value. Another way they say that is your input value. It's the number you're plugging in for. Or it's the number that, or the quantity that changes freely. Okay, this is different than the dependent variable. Now, it should kind of make sense. The dependent variable depends on the independent variable. You plug in for x, your independent variable, you get out y, your dependent variable. So that dependent variable depends on what you plugged in. It's like your solution. It's what you get out of the equation. So again, the dependent variable is going to be your y value. It's going to be your output value, what you get from plugging in the first number. It is dependent on the independent variable. So in easier words, it's dependent on the input. What you are going to find more often than not is a saying that says y depends on x. And it does. What you get out for your y value depends on what you plug in for your x value. Now, we can think about these things in real life situations that don't even have equations that go along with them. So let's think about one of those situations. So let's look at this situation. We're talking about how much money you make after selling a number of t-shirts. One of these is the independent variable, and one of them is the dependent variable. So in these situations, here's what I think you should do. I think you should read the sentence both ways with the word depends in the middle. So does the money you make depend on how many t-shirts you sell? Or does how many t-shirts you sell depend on how much money you make? Now, when you think about that, you have to sell the t-shirts first to make the money. So we know that in this case, money depends on the number of t-shirts. That would mean that money is your dependent variable, which means it's going to be your y value, and the number of t-shirts is your independent variable, which is going to be your x value. So any ordered pair that you get, any x Y is going to be t-shirts and then money. You plug in the number of t-shirts you sell, you get out the amount of money that you made. Okay, so let's look at another one. Questioning how many miles you've driven compared to how much gas you have left in your car. So, do the miles driven depend on how much gas you have left? Or does the amount of gas you have left depend on how many miles you've driven? Think about that. So, the way I see it is gas left depends on miles driven. So if that's the case, gas left is going to be your Y value, and how many miles you've driven is going to change. That is your X value. You're going to plug in how many miles you've driven, and that will give you how much gas you have left. So your X value will be number of miles. That's what it'll be for your first number. And your Y value will be how much gas you have left. So let's look at this in a real life situation. So we're looking at the equation y equals 10x plus 25. This equation gives you the amount, y, in dollars, that is in your savings account after X weeks. So the first thing I want you to do is identify the independent and dependent variables. Which one depends on the other one? Does the amount in your savings depend on the number of weeks? Or does the number of weeks depend on the amount in your savings? Well, the savings depends on what's happening in the account during the weeks. So we know that the amount depends on the weeks. And we know that y depends on x. So my independent variable is going to be the number of weeks that's my x value. And the dependent variable is going to be the amount of money. That's your y value. Okay, so now what can happen is, you know that anytime they're talking about the number of weeks, you're going to plug in for X. And anytime they're talking about the amount of money, you're going to plug in for Y. So if I can ask two different types of questions here. All right, let's talk about both of them. I can say to you, will you have $50 in your account after 3 weeks? So basically what they're asking you in that case is, does 350 make the equation true? Because 3 is weeks and 50 would be the money in your account. So this is how many weeks and this is how much money. And they want to know if that's the case. So if I do y equals 10x plus 25, I have y equals, I'm sorry, we know the y. Y is 50 equals 10 times 3 plus 25. So 50 equals 30 plus 25. 50 equals 55. Now, you will have $50 then. You have 55. If they're looking for, if the question says, will you have exactly $50? The answer is no. If the question says, will you have at least $50? The answer is yes. Because we know that after 3 weeks, it's actually going to be $55. The other type of question they could ask is they could say something like this. How much money will you have after 8 weeks? So weeks, we know, is our x value. So basically in this one, we're taking y equals 10x plus 25, and we're going to plug that 8 in for the x right away. I get y equals 80 plus 25, so y equals 105. So they're saying after 8 weeks, you will have $105. So after 8 weeks, you will have $105. So you can look at this both ways. You just have to understand that x means you're plugging in for x. That's your input value. That's the one that fluctuates and changes. The number of weeks changes, and how much you have in your account changes because of that. So you can plug in according to what they give you and solve for the other one, or you can plug in both x and y to see if it makes your statement true or not. You can also use tables and graphs to represent equations with two variables. Now the table we usually write is going to look something like this. You're going to have a line across the top. The first part of your graph is going to represent your x. That's going to be your input value, because remember, you're plugging in for x every time. You plug into the equation, y equals 2x plus 1. And you get your output, or your dependent variable, and then you're left with your ordered pair, x, y. So let's just do a few numbers for this. Let's say we're going to plug in, since we're going to plug in for x, we can pick any numbers. Let's just do 3 easy numbers, 1, 2, and 3. So I'm going to plug in 1 for x. It's y equals 2 times 1 plus 1, because x is 1 in this problem. So y equals 2 times 1 is 2 plus 1. So y equals 3. So my output value is 3. When I plug in 1 for x for my independent variable, I get out 3 for my dependent variable. Now I'm going to do the exact same thing for the next two numbers, changing my x value each time. So now I have y equals 2 times 2 plus 1. So y equals 4 plus 1, which is y equals 5. So when I plug in 2 for my x value, I get out 5. So that's 2, 5. And lastly, I'm going to plug in 3. Y equals 2 times 3 plus 1. So y equals 6 plus 1. Y equals 7. When I plug in 3, I get out 7. Now we can show the relationship between those numbers in a graph then. So I'm going to draw just the first quadrant. of my graph. And I know that my x value is along the bottom and my y value is along the side. So I know that this is my x and this is my y. So my first ordered pair is 1, 3. So I go from the origin 1 to the right and up 3. That's my first ordered pair. My second ordered pair is 2, 5. So I go to the right 2 and up 5. My second ordered pair goes there. And then 3, 7. 3 to the right and 7 up. And you can see the relationship for this graph goes in a straight line. And will continue that way as it goes through. So you can also use tables and graphs to show the relationship between the two variables in an equation. So now what I'd like you to do is read through example 3 on page 317 of the text. And then do the on your own, the number 4, in your notes. And then come back and listen to the video because we're going to go through the number 4 problem together. Okay, so I hope you read through example 3 closely and really looked at how they wrote the equation and how the table and the graph relates to the equation. So in the one you did on your own, it talked about how it costs $25 to rent a kayak plus $8 for each hour. Write an equation for the total of renting a kayak, total cost of renting a kayak. Okay, so you have to think about how these numbers are related. You see that you have $25, and that right there is a flat fee. It doesn't change. It's always $25. And then the other information, it says plus $8 for each hour. That value is going to change. 1 hour will be $8, 2 hours will be $16, 3 hours will be $24. So you know that you're going to have a variable attached to that. So this is going to be written then as 25 plus, because that 25 doesn't change, there's no variable by it, 8h. Now instead of using h, you could have used x, because that's showing that that's going to be your independent variable. That's the number that changes. So this is a good lesson. You can either always use x for your independent variable, or like I'm going to use here, you can use a variable that represents what you're missing, and that is the number of hours. This will equal the total price that you're going to pay for renting the kayak. Okay, so if we're going to make a table for this, we know that we're plugging in for h. H is the number of hours. We're plugging that into T equals 25 plus 8h. You're getting out y, or not y, I'm sorry. You're getting out T, the total price, and that will give you your ordered pair, not XY, I'm sorry, H, the number of hours, and your total cost. All right. So let's start by plugging in 1. So after 1 hour, I have T equals 25 plus 8 times 1. So T equals 25 plus 8. T equals 33. Okay, so after 1 hour, or for 1 hour, it will cost you $33. Every ordered pair has a story And each part of that ordered pair gives you information about the problem. Okay, so what you could do now is you could plug in 2, find the pattern from 1 hour to the next, or you could plug in 3 and maybe plug in every other number. It's up to you if they don't give you any specifics about what you're plugging in. So let's plug in 2. T equals 25 plus 8 times 2. So T equals 25 plus 16. And 25 plus 16 is 41. So for 2 hours, it's going to cost you $41. And we can plug in another number. Let's plug in 3. T equals 25 plus 8 times 3. T equals 25 plus 24. T equals 49. So for 3 hours, it's going to cost you $49. Now, it's asking you to actually graph this situation. If I'm going to graph this, I know that on the bottom, I have my input. So down on the bottom here is going to be the number of hours. And on the side, I am going to have the total cost. I have to figure out what's best for my intervals when it comes to my T's. Now my hours are easy. I can go by ones because I went by ones. For my total cost, I have to get all the way up to 49, and I have to go by equal intervals. So when I look at what I have, I'm thinking that maybe I can go by 5s. That would be if I have 10 markings. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't have exactly 10, and I need to get to 49. So maybe I'm going to go by 10s in this one, just to have space in the problem. So let's do that. Let's say that this is 10, and then 20, 30, 40, 50, 60. Now I really would have liked to go by 5s because it would make my graph more specific, but because I was short one box, normally in my paper what I would do is I would get a bigger piece of paper or do this problem in a different spot. So let's start with 133. I'm going to plot 1. And then 33 is going to be a little less than half. And the next one was 241. So I'm going to go to 2 and then just past the 40. To make, ooh, holy cow. I made that dot way too big. Just past the 40 for 41. And the last one is 349, so as close to 50 as I can get. And then I can take my graph and see that they connect through very nicely. So this shows the relationship between what you're spending. Now you'd be able to use this graph now to make predictions. How much would it be for 5 hours? 5 hours is going to be about 66 or 65, as you see where it is there. And you can plug 5 hours in exactly to figure it out. So if you want to see what I'm talking about here, here's your 5 hours. If I take it up to the graph and I look where it is, it's about 65 or 66. If I plug 5 in, you see it turns out to be exactly 65. So you can use this chart to help you answer more questions. Okay, this video is long enough. What you can do then is please read through page 318 in your book, example 4, and really take a look at the distance formula and the other real life application. And then we're going to try this out doing some book work. All right, good luck.